G'day, this is Andrew, and today I'm going to show you my work in progress for my latest hobby project, which is a Love2D fork of Andre Karpathy's scriptbots. So scriptbots is something that I stumbled across, I don't know, a few years ago. I think actually a friend of mine pointed me in the direction of these videos on YouTube. Chris directed me to these videos that someone had made. I don't know if it was Andre himself, but documenting a artificial life simulation, which basically had these basic agents. Well, they weren't. Well, they weren't basic agents. They were these agents with a neural network brain, and they evolved and displayed some predator-prey sort of dynamics. And that was fun, and you should check it out if you find scriptbots on YouTube. And yeah, anyway, so fast forward, I decided that I wanted to take that, which is I think written in C++, and basically, seeing as I'm learning how to use Lua and the Love2D engine, I decided to get to work on forking that project into Lua. So this has been something I've been working on for about a week. It's got a long way to go, but so this is my progress so far. So the first thing that I did on this journey was to create some agents, which are the organisms that I'm going to simulate in this artificial world. Each organism, which is just a so each organism, which I'm calling an agent. So each agent has a bunch of properties. It's got a position in the world, it's got an angle, so the direction it's facing, it starts with an amount of health, it's got an age, it's got the generation it's in. These actually don't get used yet. It has a certain color, a radius. These variables don't get used. These were Andre's for so in his agents they have wheels underneath them, and so they've got two wheels and they sort of zoom around the world on wheels. I decided to skip that at this stage at least. Small properties that don't get used, and because again this is a direct copy, so I whipped up. I decided, because I'm using the Love2D engine, I'm using the physics engine in Love to give the agents bodies. The body has a shape, and in Love you need to, or Box2D, you need to join shapes to bodies using fixtures. And yeah, so the agent has a bunch of sensors and a bunch of actuators, which then go into its brain, which the sensors are the input to the brain and the actuators are the output of the brain. And yeah, a whole bunch of other functions which are mostly just placeholders at this point, to-dos. I took the code for the brain, which is a damp weighted recurrent and/or network, and so the brain is basically just a collection of neurons, which each neuron has a set number of connections, which is basically just a synapse, or in I suppose not jargon terms, just a link from one neuron to another. Each of these links is basically the input from any specific neuron is the output from some previous neuron, right? And this is multiplied by a weight. It's either, in this simulation, it's either inhibitory, that is, it's going to add to the output. Sorry, if it's excitatory, the opposite of inhibitory, it's going to add to the output of the next neuron. If it's inhibitory, it's going to subtract from the output of the next neuron. The neurons have a certain amount of bias and dampening, which is basically just, in this case, just variables to kind of jiggle the output a little bit, shift it in one direction or the other in sort of global way. And we've got a type of neuron. So this network, there are AND neurons and there are OR neurons. So the neurons are either computing an AND function or an OR function. But it's not worth going into that just yet, because I will wind up, I'm going to play around with this because I want to be a bit more sophisticated with the brain. But at the moment, I'm just basically copying and pasting the network that Andre used. And yeah, so each neuron has connections coming into it. The brain as a whole, it will take all the input neurons, so take the input from the sensors, feed that into an input layer. That input layer is then going to send its outputs to all the neurons that it's connected to. The network as a whole is going to process, like based on the inputs, it's going to do a certain computation, and then it's going to result in the output neurons having a certain amount of activation, which then means that the actuators will in turn have a certain amount of actuation. Not going to, this is basically just the operation of each neuron. There's two types of neurons. So there's, in this case, we're doing a computation, an AND computation. In this case, we're doing an OR computation. But I'm just going to speed through that. And yeah, a whole bunch of other functions which are to be updated at this stage. And so at this very early stage, all of that gives me, if I run the program, I get a whole bunch of agents. So each of these dots that you see on the screen, or circles, they're the organisms. Each of them has a brain, which at the moment is under the hood. It's not, so what isn't happening is that there are no sensors connected to the brain and there's no outputs connected to the brain. So the brains are randomly wired together. They start with, they've got no inputs, no outputs, so the blobs just sit there. They do nothing. And that's not very interesting. So the next part of the project, or rather what I did in the next bit of time that I had, was wire up some inputs and outputs. So if we just fast forward to this, so following untracked changes, please switch branches, am I there? Force. So, with a bit of magic, I move forward in time to, so I've added, this is something that I've added, because now I've wired up the, if I just go through to the agent, I should be able to see, yeah, so I've now defined a bunch of the sensors and a bunch of the actuators. So the agents are sensing their health, they're sensing which way they're facing. I gave them a flagella, so a tail, effectively, and that tail has a direction, and it produces a certain amount of thrust, which they sense. They sense what color they are, the amount of red, green, and blue. They sense their velocity in the x direction and their velocity in the y direction. And this is just for fun. They also sense where the mouse, the cursor, is in space. And then their actuators are their flagella, so the tail angle and the tail thrust. and they also change their color. So they've got color red, green, and blue. And so now, if we run that, so initially when I did this, I didn't put any boundary on the world, and they just sort of like zoom off and disappear into the world. But yeah, I've also, in addition to adding sensors and actuators, I've also added a boundary to the world. So what happens is they're swimming off in random directions and they get stuck because I've limited them to not going outside the window. And you can see it's not super interesting. They all, like when I start the simulation, I'm just going to start it up again. They start off in a random location and then they swim in a random direction. And that's because their brains are wired up in a certain way that's producing this output. But what I haven't done yet is any sort of mechanism for them to learn or evolve. So they just sort of swim in a random direction, and that's pretty much it. The other thing is they're randomly wired up to sense the location of the mouse, and if you can sort of see that for some of them, if I move the mouse around, they will change color. Because yeah, some percentage of them have a connection that goes from the position of the mouse to their color. And you also, I don't know if you noticed that, but this guy here, I'm pretty sure he's got some sort of connection between the mouse location and the amount of thrust he's getting. As you can see that as I'm moving the mouse around and he's starting to, or it, I should say, is starting to swim, and yeah, see I move the mouse all the way over there and he's swimming away from it. But yeah, so not super interesting just yet. Bit of fun, but not so great. So what's next? Oh yeah, so the next thing I did, I mean that was all well and good. We've got them got a little bit of input and output happening, so good good first step or second step. So the next thing is to give them a bit of metabolism. So if I go to my next marker, so up to number 2, I'm at number 2 now. Okay, so yeah. So what did I do for this one? So now I've added a metabolism, so their health. Now I've got a function, so the function for the agent, the update function for the agent. I've basically split it up into, just ignoring this for the moment. I've split it up into 4 steps. So at the start of each update step, the agent does some metabolism. It senses the world, it thinks, and then it acts. So the metabolism is just it's the process of updating its health based on whatever it's consumed in the previous step, or this step, I suppose. It then senses, so it scans its sensors, which at this point are just those wires to the health. So it senses its own health, it senses what's color, it senses its velocity, it senses where the mouse is. And then, so it updates those, sends that, so it thinks, so that input then goes into the brain processes, and ultimately comes up with some set of outputs for the actuators, and then I go through and have a function here which just iterates through the actuators and updates them each in turn. And yeah, so I've added, in this update, I've added food and the metabolism. So over time, each of the agents' health, I'm just using a very simple linear function that with each step in time, the health is going to decline by the time step multiplied by just some arbitrary scalar. And when it gets to 0, I'm setting a flag here to say that the self is dead. And then up in the update step, if we're dead, then destroy the body. And yeah, there's also some additional stuff in in the main function, which basically is just some basic garbage collection stuff to make sure that we're not destroying the body, or rather, so what is there? Some additional stuff in a lot of overkill stuff. The food is there, but I was saying, so we go through our entities. Oh yeah, this I took from the course I'm doing. Basically, so we've got a list of destroyed bodies, which we keep. So it starts off empty. It's a list of destroyed bodies here. And we just go through all of the entities that are in destroyed body, check if the body is destroyed, otherwise destroy it, and then I think we empty it. And how do we do? Oh, we don't do any. Oh yeah, we just destroy it. So the body in this case is the physics object. So the actual agent still stays around in a dead state, and that's just the reason I decided to do that is just I don't know. It's just so that I could get a view of who's dead and who's alive, and they don't just disappear immediately. They hang around, but they're just no longer a physical entity. And yeah, so where was I? Yeah, so the health is declining over time, and so I've also added food. So I've created a new class of stuff, which also has a position in the world and an amount of health, and it's a physical object, and it spawns randomly in the world over time, and when I've got a collision callback function here, so when the agent bumps into the food, the agent eats the food. The food has been eaten and is I set a flag to say to remind me to destroy the food in the future. Oh yeah, and I add the food to destroyed bodies list. And then we update the agent's health with the amount of health from the food. So in the future, this will hopefully get the agents to go for the food with the most health. But for the moment, it's just, yeah, eating and dying. So this looks like this. So the food particles are these little squares here. And they're different colors based on the amount of food, like health content. And yeah, so my agents, they're still more or less just randomly floating about. They're not any more intelligent than they were in the last iteration. But yeah, now if they don't eat over time, they die. And each of these circles is the location that an agent was when it died. And yeah, they're no longer physical entities. You can see like this guy's just running right through a bunch of his dead comrades. And yeah, so that's pretty much it at this stage. Yeah, so they're moving around, they're eating and dying, and thinking. And yeah, so there's obviously quite a way to go here. I've got to work on getting some reproduction. So I need to have reproduction in some future update. I need to have some sort of mutation mechanism. And I want to have a mutation mechanism that is kind of genetic, so that occurs over the reproduction cycle. But I also want to have a mutation mechanism that occurs within the life, like a mutation mechanism on the brain of the organism that occurs within the lifetime. not quite sure how I want to go about doing that, but I'd really like it to be coupled to sort of positive and negative events that occur. So in the case of a positive event, like twiddle, like so when the agent eats some food, say, a whole bunch of synapses will readjust their weights. And like I said, I'm not really super sure exactly how I want to go about doing that, but basically I want to, the idea would be to model some sort of learning mechanism so that I guess maybe strengthen some active synapses given some rule, maybe just do a simple Hebbian learning style algorithm, or I don't know, maybe something more sophisticated. But yeah, the other thing I want to do, and this is what I've been spending this weekend on. So everything you've seen here, that was what I did over the course of the week. So, you know, in my evenings. This weekend, what I was doing was I thought it would be fun, like, because the agents' bodies are just at the moment they're just like static disks basically, and that's cool and all, and it's easy to model, and I might leave it mostly that way for quite a while I develop the reproduction mutation algorithms. But what I'd like to do is actually make it so that the agents have a more fluid body, and so basically their bodies are going to be defined by a set of vertices, and each of those vertices will be independently mobile, and each of those will be coupled to some sort of sensor, um, um, and yeah, so I did a little bit of that over this weekend, and I'll just go to. So, what is, where was I a moment ago? Because that's where okay, test polygon body. So, check out test polygon body 0. Okay, so this was my first, I suppose, test of this concept, and oh, I only have one here. Just bear with. Population is, let's make population 30. So yeah, what? That did nothing. Why did that do nothing? For I in agents, give me one moment. For I equals 0 to 30 agent, they're all in the same position, that's why. Okay, scratch that. Alright. Yeah, there we go. So, 30. Let's make it more like 60 or something. Let's not spend too much time. Oh, 900. That's gonna kill my computer. 90. Okay. So, where was I? Yeah, so independently moving vertices. So this is the first iteration of that. Just my intention initially was to use the polygon or the chain shape in box 2D, but it's not clear to me that I can use those. So box 2D is the physics engine that I'm using, and in box 2D you can define the shape of the physical object, and that determines its collision boundary. So how it's going, like when it's going to collide with other things. And it's not clear to me that you can update the shape over time. It seems like I'll have to create new shapes every time I change the polygon, which I'd like to be changing the polygon on every frame, which I'm not sure I'd be able to get away with in a simple way using the polygon or chain shape in box 2D. So this first test has no physics associated with it because yeah, I couldn't work out how to do that with box 2D. So what I did here is I've just what did I do? So I've got my agents. Where are they? Agents. So I've just created a whole bunch of actuators. So I created a whole bunch of points, and they start off in a basic hexagonal pattern. Yeah, so 16 divided by 2 makes 8 points. That's an octagon, not a hexagon. So I have my hexagon with a bunch of points, and each of those points is independently mobile. And so over the course of the simulation, these independently mobile points move in random directions, and then you get this kind of hodgepodge of the sort of art that I made back in when I discovered MS Paint in 1995. And that's kind of fun, but not really what I want to have happen. So I had to do a little bit of pondering on this, and I decided that instead of what I actually wanted to do is, where are my tags? So body test 0. So what I ended up deciding to do was to go back to box2D, but instead of using a single body to represent, and this is where we're gonna create some confusion here. So to represent the body of the organism, I want to use more than one physical object. And so that's multiple box2D bodies. And so what I wind up doing is creating a new box2D body for each vertex of that polygon and linking them with effectively springs, which in the language of box2D is a thing called a distance joint. And so if I just go to this one here, yes, you do know this. What? No, 0, 0, 1. 0, 0, 0. And I want to force this because I did just make a change, sorry. Playing. Okay, so now this, I want to close that. I don't want. Oh yeah, so I've created this new dummy class, which is similar to my agent, but has no brain. So it's just the bare bones of my agent. Doesn't have a brain. It's just something I'm using for testing the polygon body dynamics. And so this is the first iteration of that. And so if I can get this to run today. Yeah, okay, so this is my, so each of these, now are they cyan or green? No, they're green, no, cyan. Okay, so each of those cyan dots is one of these vertexes. The vertexes are physically simulated circles with a mass, a position, and velocity. And each of the yellow edges is a link between two vertices. And there's a hidden vertex in the center here, which doesn't get rendered but does exist. So there's a central vertex there, which all the vertices are linked to. And that just provides a little bit of rigidity to the organism. I'm kind of not sure if I like it there or not. I think if there's an easy way of getting rid of it, I'll show you what it looks like without it. I think I can just, oh yeah, I can just get rid of it by not connecting anything to it. And yeah, and let's just turn gravity on so that we can see what it looks like when the thing starts to bobble around. So it's gonna fall off and hopefully, yeah, it's going to go splat. And so that's why I added that central vertex, which is connected to everything, because now when it falls, whoops, I want to show you that. Okay, go back. Okay, so now when it falls with a central vertex, it's going to deform a little bit and bounce back, and it's going to kind of wobble around like, well, like I guess a jellyfish or something. And yeah, so ultimately, I want to replace all of these basic agent disks with something like this, where each of these vertices is both a sensor and an actuator. So it's going to be able to sense what's close to it, and also it's going to be able to move independently. And yeah, I've been playing around with. I spent the rest of this weekend, so that was Saturday, and then all of Sunday today. I've just been playing around with, and I'm gonna have to force this change. Been playing around with just creating a kind of graphical, well, yeah, just the I don't know. I don't even know if I want to call this. I don't know what I would call this. But I've been adding a little bit of user interaction. So I can click on a vertex and pull it around, and the body will follow it, and been playing around with just deforming it in various ways and watching it do its thing. And yeah, ultimately I want to get rid of this central vertex because I want the organism to kind of let's see if I can grab another vertex. I want to have some sort of logic, and I was just going to go crazy. I want to have some sort of logic where it keeps a fixed area, or at least it springs from a fixed area. So the body itself is going to, what I'd like to have happen is make it so that the internal area exerts a force on each of those vertexes, so pushing it out or pulling it in, and that force is going to be proportional to, I'm going to stop that spinning if I can. No, I can't. Screw it. So make it so that there's a force that is proportional to the area of the body, and so that ultimately I think if I can do some sort of like something like that, I might be able to get rid of that central vertex and let the body be a bit more fluid as a result, but still not allow it to totally implode in on itself, because there'll be some sort of internal resistance to letting the area go to zero. But yeah, one other thing that I'd like to do, and I'm just going to turn off the physics for this to talk you through what I'd like to do next. Just turn off physics. What I'd like to do is have it so that the so I want to have something like endocytosis and exocytosis, or specifically endocytosis. So I want to have like, this is not something I want to hardwire, or I'm gonna have to think about how to program this, but I want to have it so that if, say, the body winds up in a configuration like, I don't know, something like this, and something a little bit more, so it needs to be a bit more like, so I need to fix up the polygon rendering too, but if it can somehow get into a situation where it's got, I guess, a convex or concave shape, and so it's got this concave shape here, and it's got something like this happening, where, so okay, this is kind of what I want to. So you have this one so this sort of internal capsule, and these four vertices here defining a kind of channel to the outside. What I'd really like to have happen is for these, so the edge here and the edge here, to flip such as to create a situation where we have one donut polygon, or kind of one like one circle and another circle inside it, and these become two separate entities. And then anything that happens to be trapped inside this central ring winds up getting absorbed by the outer body. So effectively mimicking a process like endocytosis. Now, there's quite a lot of this is at the moment beyond what I can do easily in a weekend. So it's going to take some time to get there. I think my first challenge is just working out the logic for doing an edge flip style operation, given how I've defined my given how to find this agent. The other thing is, I think determining if one polygon is inside another isn't going to be too difficult. I can do that on a point-by-point basis and just say if all points are inside polygon A, then, you know, go to metabolism process. But I think I'm going to want to do some sort of, I think the problem is going to actually be in deleting and recreating polygons. So I think I'm going to have to do some sort of sneaky something where once we're in this configuration, what actually happens is we create a new polygon which matches these vertex locations, and then in that same step, these vertices immediately spring back to this location here, or these ones move across and the others spring back to that location. That happens in the same instant. So we're never actually adding or deleting vertices, or rather, we're never deleting vertices from the agent's body. We're just adding another totally new polygon. Yeah, so I guess there's that's pretty much it. So yeah, hopefully there will be some updates hopefully there'll be quite a little bit to come in the next week or so. But yeah, I've got quite a lot to work on. But yeah, if you're watching this, I hope you enjoyed it. Cheers.